a lot of this was just a way to cope with my terror, was just to be able to know what's going on.
There is the potential for an output of carbon, both in the form of methane and CO2, and that could severely punctuate the warming that we're already seeing in the atmosphere if it were to be released. But then you also have threats from infrastructure destruction, because the ground below the infrastructure in much of Canada and much of the northern hemisphere has the potential to fall away.
Some have characterized permafrost as a time bomb. I think it's more like a wildfire that's already doing damage. We know for sure that it's going to grow, and what we are unable to determine exactly is how fast and how much.
There has been historic methane trapped under the seafloor. As the seawater warms, it warms the permafrost underneath, and it causes the release of large bubbles that are filled with methane, and they bubble up through the surface and go into the atmosphere. I'm not trying to frighten anybody, but the predictions are frightening as to how much methane there may be in the seafloor and what accelerated warming will mean for the release of very large quantities of methane. This feedback between climate warming and the potential release of methane from frozen areas of the north, both permafrost and seafloor, are not included in climate models at this time. So some of the implications you see for the warming of the Earth do not include these feedback mechanisms.
Well, good evening, everyone, and welcome to Environmental Coffee House. Hi, Jennifer. How you doing?
Hi. I'm
Hi.
doing good. How are you?
I'm okay
Hanging
now.
in?
I wasn't well because, again, I went to the antique store, but not to work, to sit there with my friend for a few hours on Thursday. And once again, whatever is in there, that was it. I had a migraine. I was sick for, it's like a 48-hour thing. I don't know if it's the store or what, but I'm here. I'm back. Hello, everybody. Everybody's here. Hunter and Kim are mods, and I think Kameshwari Kate might be coming. Raza, gosh, Warren, everybody's here. Hans, Lone Wanderer, Christopher, Billy Joe, Trulia, Poppy, James, Christine, Lorna Ray, Benny Loco. Hi, Benny Loco. Hi, Benny Loco, Benny Loco. So there's J-Cat. Okay. We got a good show tonight, Cindy Sealy. What I wanted to do, guys, was really quickly show you just something that I took. Look at that guy.
Oh.
He was in my yard. That's right
Oh,
outside my
sweet.
office window. What a sweetheart is right. Look at that little guy right out my window. They're fat. They made it.
Oh, they
made it.
are.
They're doing pretty good. They probably raid my compost. That's what I think.
Yeah.
Yeah, that's what I think they do. So I'm just fixing you a little bit here, and tell us what's going on in your life, your neck of the woods.
Oh, well, everything is good. No fires. We've had a lot of cold weather, but you have too. We've had a lot of
Yeah.
snow. And I'm hoping that it will pass and it'll be nice out. But it's been pretty chilly,
Yeah,
thanks to
yeah.
Arctic amplification.
Thank you, Arctic
So
amplification.
thank you, Arctic
Yeah,
amplification.
thank you. We have a lot of bubbles with Arctic amplifications just bubbling all over the place. Just bubble, bubble,
Hmm.
bubble. All right. So, Arctic amplification, we will say goodbye to you for now. And Jennifer, would you like to give the 50,000-mile up view from the moon
Sure.
of what we're doing?
Okay. There you
Okay.
go. Okay, we got a great show lined up for you guys today. It's all methane all the time. You know, um, a lot of us here are fascinated with methane, and what's not to be fascinated about. So, our first article's from the ESA. It's called Permafrost Thaw. It's complicated. And then we are going to be talking about something from 13 News, W
Mhm.
something something TV. I don't know what that TV station is.
13 News
Uh,
somewhere, but they have a good article.
yeah. Where does the world's methane come from? We've got maps. And actually, that's a really good video, Sandy, that
Yeah,
they included. Yeah.
definitely.
Yeah, then we've got a really good article from the New Yorker, but we're not going to be reading it. We're just going to be referring to it because it's 48 minutes long and that would take up the whole show, and there's a audio within it included,
Yeah.
and so y'all can listen to it tonight. But this is called Letter from Siberia: The Great Siberian Thaw. Permafrost contains microbes, mammoths, and twice as much carbon as the Earth's atmosphere. What happens when it starts to melt?
It's a good one. I suggest
Yeah.
everybody before you go to bed, relax, either your headset or you're not, listen to this article. It's great.
Yeah.
And then you don't have to listen to us for 48 minutes because it's a long one.
Indeed, indeed.
Yes,
And
indeed.
then we have one from phys.org. Thawing permafrost can accelerate global warming, by the University of Cologne.
Okay.
And then we have one from Copernicus. And Sandy, I think that you're going to just be going through this a little bit. Emissions and surface fluxes.
Yes.
Is that the one?
Yeah, I'm just going to
Yeah.
show them the website because Paul Beckwith already did a whole show on methane this week, and it's really good. So, of course, we always
Okay.
say go on over to Paul. He shows you things
Well,
and we do the news.
yeah. Yeah.
Yeah,
Yeah, I just listened to Paul's newest one yesterday too. He has a great, well, it's not his newest one, but it's his newest methane one. You
it
can
is.
find
It's
it.
good.
It's about 4 or 5 videos back, and it's about 50 minutes long or so. But if you're a methane nerd and if you like charts and graphs
Like we
and you
are.
want to know, yeah, and you want to understand exactly how it all works, watch Paul's
Mm-hmm.
videos. Very good.
Great.
Okay,
Great.
and then we have one about polar bears, and it's from
Yeah.
Live Science. See first ever photos of polar bears playing house in the Russian Arctic. So this is kind of like our light news. Decades after people move out, polar bears move in. So it shows all these polar bears inside the houses. It's so cute.
Yeah, so we will definitely look at that one to end up with something on a little lighter note. And well, I guess we'll get started. This
That's
first
it.
one,
Yeah.
what I'm going to do is get the first one started. And guys, while we're doing that, here we go. All right. And the background will be this. There we go. Permafrost thaw. It's complicated. And Jen, do you want to tackle this one? You want to do this
Either
one?
way, you just let me know. I'm just kind of your happy
Well,
sidekick.
you're not my sidekick, hon. You're the star of the show. You know you are. All right.
No.
I'll tell you what. We'll tag team it. How's that?
All
Let's
right.
tag team
All
it.
right.
I'll start real
All
quick
right.
and then you can bring up the rear, and there's some graphics. And all right, so not that our audience knows because we do go over this, but one of the many serious consequences of climate crisis is that precious permafrost is thawing, and this is unleashing even more carbon to the atmosphere and further exacerbating climate change. However, it's complicated. For example, sometimes the permafrost can thaw rapidly, and scientists are unsure why and what these abrupt thaws mean in terms of feedback loops. This makes it difficult to predict the future impact on the climate. Thanks to the ESA NASA initiative, new research digs deep into understanding the complexities of permafrost thaw and how carbon is released over time. Take it away, Jen.
Permafrost is frozen soil, rock, or sediment, sometimes hundreds of meters thick. To be classified as permafrost, the ground has to have been frozen for at least 2 years, but much of the subsurface in the polar regions has remained frozen since the Ice Age. Whoa, it's a long time.
Whoa.
The end of the last Ice Age was about, 12,000 years ago, approximately. Permafrost holds, and that was the end, not the beginning. Permafrost holds carbon-based remains of vegetation and animals that froze before decomposition could set in. Most of Earth's permafrost is in the northern hemisphere. Arctic permafrost stores almost 1,700 billion tons of carbon. Woo! That's a lot. And it says the animation below shows how the extent of the permafrost in the Arctic changed between just 1997 and 2019. So this is just a little over 20 years. This is just 22 years. So that's pretty interesting. It's cool animation, Sandy.
Yeah, it is. Let's look at that real quick. I'll pull that up.
Yeah.
And it's let's see. Okay. Click.
Yeah.
Let's see what it does. Oops. Wait a minute. Do we want that side? No. We really don't. We just want to show you the big picture, the animation. See, it's the permafrost and it's the fraction and it goes from 1997.
And you can see how it is kind of getting bigger, the amount that's getting unfrozen. Permafrost plays a critical role in keeping our planet from losing its cool, but the rise in global temperatures, particularly evident in the Arctic, is causing the subsurface ground to thaw and release long-held carbon into the atmosphere. The image below shows how the subsurface is warming, risking permafrost thaw. Well, that's pretty interesting. You can see the biggest permafrost thaw is over in the Laptev Sea. Yeah.
Yeah, there you are.
And consequently, that's also one of the areas of biggest methane deposits. So anyway, but it's really hitting Siberia across the board. From the Kara Sea through the East Siberian Sea, the permafrost is thawing mostly in Siberia, more than in Canada, looks like, more than in Alaska.
Oh, but it is there too. But from this one, definitely.
Yeah.
Absolutely.
Oh, yeah, definitely. Highlighting the importance of permafrost in the climate system, the Journal of Nature Reviews Earth and Environment recently featured a wealth of research papers in a special collection that examines physical, biogeochemical, and ecosystem changes related to permafrost thaw and associated impacts. One of the papers in the collection is based on the research conducted through ESA NASA Arctic Methane and Permafrost Challenge. The paper describes how scientists from Europe and the US are working together to better track permafrost carbon dynamics. This includes gaining better understanding of the mechanisms that lead to abrupt thaws through the use of key observations of carbon release and developing models to predict permafrost carbon feedback. That's interesting. So I guess this image down here below shows the amount of carbon stored in the upper 2 meters of permafrost.
Mm.
Whoa, that's a lot.
Look at it. Yeah. Wow.
That's interesting.
Mm-hmm.
That's really interesting. Abrupt thawing and thermokarst, which is a fast process of permafrost degradation, but varies significantly depending on local conditions, can emit substantial amounts of carbon to the atmosphere very quickly, even in a matter of days. These processes risk mobilizing the deep legacy carbon sequestered in Yodoma. Yodoma is a type of permafrost that is formed between 1.8 million and 10,000 years ago. Wow. It's ancient permafrost and is particularly rich in organic material, so a significant source of atmospheric methane. Wow. So ancient permafrost is starting to thaw. Increasingly, frequent wildfires in the Arctic will also lead to a notable and unpredictable carbon flex. The paper's lead author, Kimberly Miner from NASA Jet Propulsion Laboratory, said, quote, the traditional view of permafrost thaw is that it is a gradual process that exposes layers slowly. No, no, no. Abrupt thawing exposes old permafrost layers far more quickly. Interesting, huh?
Very.
Yeah.
I guess I
Do you
was
want to
right.
take over or do you want me to
Okay,
keep
where
reading?
am I? I was looking at the chat.
Right under the picture of
This one.
discontinuous thermokarst
Okay,
landscape.
sure.
It says scaling.
Scaling is a real challenge, but our research focuses on understanding emissions of carbon across different time scales, from the microbially mediated release at soil level to wildflower dynamics across the tundra. Similarly, we need to use observational methods across the scales, from in situ fieldwork to satellite observations to mirror thaw timescales. Only with data covering days to years to decades can we substantially reduce uncertainties in our understanding of what may trigger rapid thaws, predict emission rates, and then have a better picture of those feedback cycles. So, Jen, as long as we've been talking about this, there's always new papers. There's always new, and of course, we're not reading the scientific papers. We bring you stuff from what's in the news. You know, what's in the publications. So, Charles Miller, who's also from JPL, the Jet Propulsion Lab, like Peter Camus, by the way. I think he's from that same place. Our understanding of permafrost is, of course, advancing all the time. Permafrost, it cannot be directly observed from space. No, we have to combine different measurements such as land surface temperature and soil moisture to give us a picture of that change. And thanks to satellites, we have a record going back over 20 years that changes to the northern hemisphere's details the changes to the permafrost soils. And this is key. It's a key to improving those climate models. So, however, we look forward to future in situ measurements and future satellite systems to give us more information. ESA's Diego Fernandez added, thanks to missions such as ESA's SMOS and Copernicus Sentinel-5P, the research being conducted as part of the ESA NASA Arctic Methane and Permafrost Challenge within ESA's future EO program and ESA's Climate Change Initiative is once again proving essential to better understand the effects of climate change that is having on the delicate Arctic environment and how these changes in turn add to the climate crisis. So, as part of the Arctic Methane and Permafrost Challenge, ESA and NASA aim to support strong scientific collaborations from both sides of the Atlantic to tackle jointly the scientific and societal issues associated with permafrost thaw. So, in the future, upcoming missions such as the German, French Merlin which is planned to launch in 2027. Oh my gosh. Uses laser
Mm.
technology and shows promise to add valuable methane data to the Arctic observing system. So, also, the Copernicus carbon monitoring mission, which is scheduled to launch in 2025, will provide high frequency data to better monitor carbon emissions from the thawing permafrost. So, these guys, what are they doing here? They're measuring greenhouse gases. Wow.
Wow.
Wow. That's
Interesting.
pretty wild how they do those
Yeah.
with the things. I guess I'll finish this one. Groundwork is also essential for understanding how greenhouse gases are being emitted from the Arctic. For example, last year, the ESA, European Space Agency, was involved in an international research campaign based in Sweden. The monitoring of the atmospheric composition and the greenhouse gases through multi-instrument campaign included launching balloons into the stratosphere, flying instrumentation on aircraft, and taking measurements on the ground to record climate gas sources and sinks in Scandinavia. How cool. Similar activities will
Hmm.
be continued in the North American Arctic in the summer of 2022. Oh, coming up. That's awesome. As a part of the Arctic Boreal Vulnerability Experiment and the carbon dioxide and methane mission. Both of these airborne campaigns are led by NASA and the German Aerospace Center, respectively. So I like that because that's a pretty that's well, I don't know if we've ever used this one before, the European Space Agency
I
publication,
don't
but
recall
no,
that we've used this before. No,
yeah, I think we're going to have to keep an eye on what they're doing. It's pretty interesting stuff. Wow.
totally.
Yeah.
Yeah.
So we're going to move on. We're going to move on to this one because there's also a really good video here, guys. And Jennifer, I'll let you start with this
All
because
right.
it's your turn.
It's my turn.
It's your turn.
Okay. Where does the world's methane come from? We've got the maps. And when do you want to play the video? Do you want me to
You
read
tell
for a
me.
while and then you play the
Tell
video?
me when you want me to play it, hon.
I don't
Whenever.
remember if it has words or not.
Well, it's right here. I have it set up. I have it queued if you guys want to see it. Why don't we play the
Yeah.
video? Let's play the
Okay.
video. Let me get it ready and we shall play this whole beautiful video. It's not that long. Okay. Here we go.
This year, NASA released a new visualization modeling the sources and transport of methane across our globe. With this new visualization, we can see how methane sources vary by location and season. In South America, the Amazon River basin and its adjacent wetlands flood seasonally. This creates an oxygen-deprived environment that is a significant source of methane. In the last 200 years, methane concentrations have more than doubled, mainly due to human activities. Europe is the only region to show a decrease in methane emissions over the last 20 years. In India and Southeast Asia, rice cultivation and livestock are two of the driving sources of methane. In China, economic expansion is driving a high demand for fossil fuels, resulting in an increase in methane emissions. This is a stark difference to the Arctic, where natural sources, such as natural wetlands and potentially thawing permafrost, account for more than 70% of the region's methane emissions. Taking a step back, we could see that methane has vastly different sources around the globe. By getting a better sense of the story of methane, scientists and policymakers can better understand the sources of methane emissions and work to reduce this greenhouse gas.
Yeah, that was nice. That was definitely
Yeah.
nice.
That is a
Okay.
high quality video. Yeah.
Let's get us back.
Okay. Let's go.
Let's go, let's go.
Seawater seeps into the cracks in the ocean crust and collects underground.
We don't want that. We're going
Okay.
back. All right.
Okay.
Let's go back and I will fix us up. Go for it.
Okay. The visualization presented here that we just saw in the video shows the complex patterns of methane emissions produced globally between January 2018 and November 2018. So just within 2018, almost a full year, but not quite, from different sources. Methane is a powerful greenhouse gas that traps heat 28 times more effectively than carbon dioxide over a 100-year timescale. Concentrations of methane have increased by more than 150% since the industrial activities and intensive agriculture began. After carbon dioxide, methane was responsible for about 23% of climate change in the 20th century. It's a huge contributor, right? Methane is produced under conditions where little to no oxygen is available. About 30% of methane emissions are produced by wetlands, including ponds, lakes, and rivers. Another 20% is produced by agriculture due to a combination of livestock, waste management, and rice cultivation. Activities related to oil, gas, and coal extraction release an additional 30%. The remainder of methane emissions come from minor sources such as wildfires, biomass burning, permafrost, termites. Termites. Who would have thought termites? Dams and the ocean. Scientists around the world are working to better understand the budget of methane with the ultimate goal of reducing greenhouse gas emissions and improving prediction of environmental change. So that's it.
Cute. That was a cute little one.
Yeah.
I thought it
Yeah.
was. Yeah. Now we have the big one, the New Yorker, but I'm going to show you guys. See how the New Yorker has it. You could listen to the story and it's 48 minutes. But what this has is a lot of information. And it says it contains the microbes, mammoths, and twice as much carbon as Earth's atmosphere. What happens when it starts to melt? Now, of course, we've read to you, we've covered this over and over. However, there's always something new. And the problem is you can't just turn it off, let alone reverse permafrost thaw. One scientist said it won't be possible to refreeze the ground and have it go back to how it was. It won't. So,
No.
basically, they're going.
See,
this
that's
is
a thing that we really should emphasize a minute,
Yes.
Sandy, before we go
Emphasize
on,
it.
because people always, well, not us, but other people, think that, well, if we we who know.
We who know.
No, it's worse than that. But people think, oh well, if carbon dioxide emissions just stop, which is kind of like, let's see how that goes. It hasn't done it yet. Then everything will just go back to normal. That's not the case. It's going to take a
No.
concerted amount of cold to refreeze that permafrost, if ever. It's going to take like another ice age, right?
Yeah, and it won't be a bunch of mirrors.
Mm-mm.
Sorry. All right.
So I'll let you
anyway,
handle this
what
one.
I'm going to do
however-
is I'm going to tell you about the author, okay? Because I do like to. This guy, he's a Moscow correspondent for the New Yorker. He's the author of Between Two Fires: Truth, Ambition, and Compromise in Putin's Russia. So he writes a lot of stuff for this, for the New Yorker, and obviously he's Russian, so he's writing
Yeah.
about what he knows in his country, and he starts out by talking. I hate these advertisements. That's why we're not going to do this one. But we want you to. He talks about flying over the
Okay.
Yakutia in northeast Russia, and then he's going all the way through his trip. He's going to tell you a whole story. And honestly, guys, I really think that you should listen to this one. Please don't like just leave us and not listen because really we didn't want to do this for the 45
Yeah.
minutes. But he talks about the fewer than 200,000 people that live in the Arctic reaches of Alaska and Canada. There are no large towns. The Soviet Union, by contrast, sought to populate its northeastern territory. So he's going to talk about that and the construction, and it's a
Mhm.
full on article. And like I said,
Yeah.
48 minutes. You guys listen, and I'm going to test you in the next show.
I see he also talks about Norilsk and Nornickel.
Yeah. Oh, yeah.
About
This
the
is
fuel storage tank that
it's a comprehensive
cracked.
article. Yeah, absolutely. So, and she frustrated atheist read it. Very good article, kept me
Oh,
awake.
good.
All right, good. So somebody knows the article.
Good.
We're not going to read it because we're going to move on. We're going to move on over to. I mean, as much as we really wanted to read this, again,
It's too big.
the test will be next Sunday. So we'll do the Fizz org. Okay.
Okay.
Because yeah. And Jen, how do you want to do this one?
Yeah. Either way, I can read it if you wish.
Go for it. And I can play with the
Okey-doke.
chat. If you guys have questions, remember to put two Q's in front of it. And then I can go back. So far I only have 3.
All right.
All right.
So, thawing permafrost can accelerate global warming. This is kind of like, yeah, really? No kidding, right? This crowd.
I think we
Thawing
need the silent
permafrost.
vortex. Yes, read it. Go for it. We're reading with the
Thawing
vortex.
permafrost in the Arctic could be emitting greenhouse gases from previously unaccounted for carbon stocks, fueling global warming. That is the result of a study conducted by a team of geologists led by Professor Dr. Janet Rethmeyer at University of Cologne's Institute of Geology and Mineralogy, together with colleagues from the University of Hamburg and Helmholtz Center in Potsdam, GFZ, German Research Center for Geosciences. In the Siberian Arctic, the research team determined the origin of carbon dioxide released from the permafrost that is thousands of years old. This research endeavor is part of the German-Russian research endeavor oh God help us, Kohlenstoff im Permafrost, funded by German Federal Ministry of Education and Research. That's also known as the BMBF, in case you didn't know. The research has been published in Frontiers in Earth Science. Global climate change is causing temperatures to rise sharply, especially in the Arctic. Among other things, higher temperatures are causing more and more permafrost soils, which have been frozen for thousands of years, to thaw. Particularly affected is the so-called Yodoma permafrost, which is widespread in areas that were not covered by ice sheets during the last ice age. Yodoma contains up to 80% ice and is therefore also called ice complex. The ground ice can thaw very abruptly, causing the bedrock to collapse. The bedrock, think of that. The bedrock to collapse.
That's
and
hairy,
erode.
Jen.
That's insane, right?
Mhm.
Such processes, known as thermokarst, make carbon previously stored in the frozen ground accessible to microorganisms, which break it down and release it as carbon dioxide and methane. The greenhouse gas release amplifies global warming, which is known as permafrost carbon feedback. So far, there are still many uncertainties about the amount of future greenhouse gas release. Among other things, it is not clear how well the ancient carbon that has been frozen in the permafrost for thousands of years can be degraded. To find out, the research team took carbon dioxide samples at the Siberian investigation site on the Lena River using specially designed equipment in which carbon dioxide can be stored airtight and transported manner for long periods of time. This is necessary due to the long transport to Germany. Back in Cologne, the researchers then determined the age of the carbon dioxide using the radiocarbon method. In addition, they analyzed the non radioactive carbon isotopes. Both parameters were used to calculate how much old and young, as well as organic and inorganic, carbon had been decomposed in the thawing permafrost. A large proportion of the carbon, up to 80%, comes from ancient organic matter that was freeze locked into the sediments more than 30,000 years ago. This means that vegetation remains that died thousands of years ago have been very well preserved in the frozen sediment, making them an attractive food source for the microorganisms
Oh,
in the
yummy.
thawing permafrost. Yum, yum,
Yummy.
yum.
Yum, yum, yum.
In addition, the team found out for the first time that up to 18% of the carbon dioxide comes from inorganic sources. It's not all organic. Quote,
No,
we did
everything's
not
organic.
expect that this previously unnoticed carbon source would account for such a high proportion of the total amount of greenhouse gases released. So, for more precise climate prediction, it would be necessary to take this source into account. Future research will have to clarify where exactly the inorganic carbon in the Yudoma comes from and through which process it is released. So, Sandy, there's something I want to bring up.
Bring it up, babe. Bring
And
it up.
remember, like, I don't remember, 6 months ago or something, we were talking about the inorganic methane coming straight out of the rocks in Novaya Zemlya, right in the
Yes.
Kara Sea. And there's like this ridge of limestone at the top of Novaya Zemlya, kind of like the spine of it. And
Mm-hmm.
methane was gassing out of there. And that's an example of an inorganic source of methane.
Inorganic.
Inorganic, right?
Mm-hmm.
So I think that these inorganic sources of methane are going to increase as well. They respond to heat as well.
And there is the anthropogenic, like Paul was talking about, which I was fascinated in his video when he showed, and I am going to show us the Copernicus page, but of course not like he does. I'll show it to you, but
Mm.
how the methane from all of the sources, all over the world, uh, it goes up about 1.5 kilometers into the atmosphere from the surface and just blankets. And then as you get higher, it's not, you don't see it as much, but it is absolutely wild. I mean, it's really
Yes.
wild. Holy crap.
Yes.
I
Eh,
was, I,
Methane
phew, methane's
methane
heavy.
likes to hang out at about 30,000 feet
Yeah.
up, right? So about 5 or 6 miles up into the atmosphere, that's where methane likes to hang out. That's its natural kind of place of buoyancy. And you go into the stratosphere, you don't see methane. And at the bottom, like at the ground, you can see where the methane is coming out. And that's interesting to note because you can see the sources of methane. There's a bunch coming out of China, Southeast
Yeah.
Asia, India, from organic sources. In China, a lot of it has to do with coal mining. It's
Oh, yeah,
also
it does.
organic sources like all sorts of farming and livestock and rice paddies and things like that. So it's very interesting. That I just learned all from Paul's video.
It was a great video, guys. I'll
Yeah.
even put the link in there. I watched it. I watched it twice.
Oh, yeah.
Because, yeah, it's one
Yeah.
of those that you just have to watch. But our next article, well, what I'm going to show you guys is I'm going to show you the Copernicus site. And it's Copernicus Atmospheric Monitoring Service. And emissions, this particularly is the emissions and surface fluxes, the exchange of pollutants and naturally occurring substances between Earth's surface and its atmosphere drives the composition of the atmosphere. And CAMS provides consistent data sets for use in air quality and climate models. And here at this graphic just shows us the 78% nitrogen, 21% oxygen, 9% argon, 4% carbon dioxide. Let's see if I can get a spec in here.
0.04.
Oh, yeah, 0.04. I was
0.04.
playing
And
at the same time.
0.9%
Yep,
argon.
0.9%, and a few trace other components. I'm multitasking and sometimes multitasking. So do you want to talk about this? This is all the methane from us, not from permafrost. This is what happens
Yeah,
here.
absolutely. I mean, our atmosphere is mostly nitrogen, and then we have about 21% oxygen, which is going down, down, down. The thing that's heating up our atmosphere primarily is carbon dioxide, and you can see it is not 4%. It is 0.04.
0.04.
No,
Sorry.
it's not.
No.
It's not even 0.4. It's 0.04%.
So I have to pay better attention.
Well, it makes a big difference. It really does,
difference.
because carbon is counted in parts per million. So we are currently at 400, 1720, whatever, parts per million of carbon dioxide. So that's why it is 0.04% carbon dioxide. And it's I think you already read this. Some of these exchanges occur naturally. Did you read that already?
I read the top, but I didn't go down here where it talks about the inventories.
Yeah.
And let's see. It compiles the inventories of emission data that serve as input to the atmospheric chemistry transport models. These inventories are based on a combination of existing data sets and new information describing emissions from fossil fuel use, ships, volcanoes, and vegetation. This ensures good consistency between the emissions of greenhouse gases, reactive gases, and aerosol particles and their precursors. So the CAMS emission inventories also extend existing data sets forward in time, producing timely input data for the forecast models. So it also gives you that information on estimating the fluxes of the CO2, NTO, and CH4 at the Earth's surface using satellite and the in situ observations. So CAMS is very cool. That's why when we go on Twitter and like Christopher Cartwright and all these other guys on Twitter, they run all the programs and they make their graphics from this. I mean, they were I took some of the graphics earlier. I didn't pull them in, but I took some of the graphics earlier and I showed them. So while we're not giving you a tour, we're showing you the website, and the website actually it's really cool. The website, they have articles, they have news. It's not just for putting in your geeky stuff, but there's a lot of different things here. This one is the Antarctic ozone hole in context. The CAMS goes from strength to strength. I mean, it's very interesting. It was showing the wildfires back in December. So it's a great, great site. And if you have time to play with the site, you'll get some learning under your belt, huh? Yeah.
Get us some learning, Sandy. We're going to get us some learning.
Get us some learning. Get us some learning. So I have only 3 questions so far, Jen, and I wanted to
Oh,
go.
really?
Well, Hunter was talking about sinkholes, but we're not actually talking about sinkholes tonight. But I mean, we've covered them, but we sure will cover them again, because sinkholes are always something that's happening up there. And I showed it in the opening video that there are the holes with the bubbling, and just the scientist was talking about not knowing exactly how much. But well, Fred wants us to talk about real problems. Like this isn't a real problem.
Mm.
He wants the mass decline of insects, the amount of birds and others animals wiped out. So thank you, Fred. He went to bed because he's on the other side of the planet. Thank you, Fred. And Jenny and Sandy, this is from John Bell. How many times stronger is the GWP of methane compared to CO2? There never seems to be a fixed stat for that. It ranges from 26 times to 150 in a 10-year cycle. What do you say, Jen?
Yeah, well, actually, yeah, we can talk about this a little bit. The thing is about methane is that it degrades very quickly and converts itself over a certain number of years, 100 plus, to carbon dioxide. It actually degrades to carbon dioxide. So the point to know about methane is that when it first emerges in its native virgin state, it is, now they're saying, 84 times as strong as carbon dioxide within the first 20 years. And then within the next 80 years, which will bring us up to 100 years, it degrades down to about, 30% or something like that.
Wow.
It's approximate. But the point about methane is if a lot is emitted quickly, it can nudge tipping points. It can kind of accelerate things. So, for example, if the methane in the Arctic, which there are methane stores in the Arctic, huge ones, giant ones, all started to thaw out around the same time, and we're not saying that it's going to be a methane bomb
Right.
per
No.
se, but it doesn't have to explode. Maybe the word bomb it shouldn't have been used, but they used the word bomb, and then everybody went all like crazy about it. But it just means that a lot of methane can start emitting all over the place very quickly. It's not that it all comes out at once. That's a misnomer. But it will all come out very quickly if it starts to thaw out, right? All those methane hydrate deposits, they're there ready to come out, when it gets warm enough. So
Okay. Got another
I don't know if
question?
that really answers his question, but methane's a component. It's not a long-lived component. It's a component that will affect life on Earth roughly, over a couple 100-year period, right? Whereas carbon dioxide is not that way. Carbon dioxide's very, very long-lived. And one of the only ways you can get rid of carbon dioxide is if it rinses into the ocean. And then, of course, that causes ocean acidification. But the point is, carbon dioxide is a very stable molecule, and it doesn't degrade like methane does.
Well,
I don't know
James
if
had
that
said,
helped.
I'm sure it did. It helped me. James said, I think the professor and Shax said on the last Shackleton. Wow, let's play. Here's Shackleton. Wait, we have Shackleton. I actually have Shackleton
No,
here.
you do not.
Listen, there's Shackleton.
How did you? That's
There's
crazy.
Shackleton. Okay. Anyway, so James, I think the professor and Shack said in the last video that methane is accounting for increasingly larger percentage of total greenhouse gases. Yeah.
Yeah, that is true. That is
It is.
true.
It is getting
because it's coming
bigger.
out more because it is emitted a lot just by civilization. Everything we do in civilization, it seems to emit methane. If you look at some of those methane maps at the surface level, you can see where it's coming out, and it's coming out where there is the most people, right? And it is
Yeah,
a phenomenon
sure.
that's mostly limited to the northern hemisphere. There's not a lot of methane in the southern hemisphere. There's a lot
No,
in the northern hemisphere.
no, there's not. And that was very interesting to me, I thought. Christopher says this is a methane nightmare. Well, there's it's an everything nightmare if you want to use every greenhouse gas and talk about there's methane nightmares and everywhere.
Yes. Well, it
Go
is a
ahead.
methane nightmare because the thing about methane is its immediacy. It is instantaneous heating. It doesn't hang around like carbon dioxide is a more stable molecule, but on the other hand, carbon dioxide reaches its full heating potential within like 20 years. Not so with methane. Methane, once it's emitted, it starts heating up a lot really fast right
It
then. So
does.
that's the big difference between methane and carbon dioxide.
All right, let's see here. We have Jim. All right, Jim. I understood methane to be 162 times ECO2 in the first 2 years, then 80 times in the next 2 to 20 years, then then 20 times. Okay, where was I? Whoops, nope, that's the wrong
Yeah.
one. Whoop. Oh, here we go.
I've got you.
Then 20 times in the next 20 to 100 years. Question 20 times
Yes.
from 20 years to 100 years. Okay.
Yes. The point of it is, you're right, Jim. When methane is first emitted, it's like 180 times more potent, molecule for molecule, than carbon dioxide. But it very quickly tapers off. So, depending at what point you're looking at the methane story. So they started looking at it over a 20-year period, and they just used the base of 84 times. They said, okay, within the first 20 years, methane is going to be 84 times more potent, but that was an average. Now, if you want to take the first 5 years, it's going to go up to 180, right? So, because it tapers off very, very quickly in its potency.
All right, I've got another one here. I wanted to, okay, T-bone, and I might want to answer this because I just learned something about this. Wasn't the thawing of the permafrost also a so-called time bomb of centuries past diseases like bubonic plague, Spanish flu, smallpox, etc.? All right. So as I was watching my virologists, it was a topic they were talking about was the viruses that could be in the permafrost, that might be in the permafrost, that we actually right now should not get hysterical about. There will be issues with thawing out, but the strength of virility, no one knows yet. But I think that would be a great topic for Jennifer and I to do another show on because it's fascinating. So thank you for asking that, T-Bone, because it is fascinating. But, of course, I'm not going to get, freaked out over it. Jen, do you have anything to offer on that one?
Oh, well, there's so many things we can get freaked out over, Sandy. I mean, if we just talk about this stuff long enough, I will all end up having nervous breakdowns. But
Yeah, well,
we'll be happy having our nervous breakdowns because we'll know what the heck is going on.
Yeah. And Christopher, he
And
said,
anybody who listens,
right. I'm
I was
sorry.
just
I
going to
didn't
say,
mean to cut you
anybody
off.
who listens to this show
Yeah,
is very interested in
Gets it.
knowledge.
Gets
They
it.
really are interested in knowledge.
Yes.
Yeah.
Well, Christopher asks, did it say what China's percentage of world methane output was? And of course, I don't know. I just know
I
that
don't think that there's really a
huge,
percentage.
but they're in the deep red when you look at
They are.
the graphs because they're burning coal. They're now here.
Right.
You know what? We're going to give China the flush of the day because
You
actually
betcha,
they're
baby.
burning more coal. Here's to China. Burn, baby, burn more coal. Flush that away. flushing their coal and burning more coal. So of course, yeah, but we don't know that. And if it's something that we have to look up, we can. Kendra. Kendra says the methane release at first is 150, then slowly goes down.
Yeah.
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 There you go, Kendra.
Like
You're
we've been
good.
saying.
Yeah.
Yeah.
All
I
right.
mean,
All right.
yeah. Like she says, when it comes out, it's very strong. Take your pick.
Absolutely.
Um, yeah.
Absolutely. All right. Well, I think we've got some questions answered, and we have one more article that we're going to look at, and we're going to end the show with some polar bears. I think we're going to do that, and let's get the screen share up, and let's look at that. All right, let us get the screen share. All right. I don't want that. Jennifer, do you want
Mm.
to take this one or?
Oh, yeah. Sure.
All right.
Sure.
All
See
right.
first ever photos of polar bears playing house in the Russian Arctic decades after people move out. Polar bears move in. Dozens of polar bears have been making themselves at home in abandoned buildings on an Arctic island,
Oh,
and
they're
a
so
Russian
sweet.
photographer recently captured remarkable photos of bears peering through windows and standing on porches. When photographer Dmitry Koch, uh, I don't know if I said that right, traveled to the remote Russian region in northern Chukotka
Chukota.
in late is that it? In
Chukotka.
in late
Chukotka.
Thank you, Sandy. In late summer 2021, he was hoping to find polar bears to photograph on Wrangel Island. Oh, I've got to tell you things about Wrangel Island, but I'll
All
hold it
right.
till the end.
Good,
I'll
good,
hold it
good.
till the end. I'll hold
Good.
on to that thought.
All right,
Don't let me
awesome.
forget.
We won't.
To photograph on Wrangel Island. So Wrangel Island's in the Chukchi Sea. It's kind of like just more towards the Arctic, if you're kind of like where Alaska and Siberia come together and then go towards the Arctic. That's where Wrangel Island is.
Okay.
A natural World Heritage Site that's protected by the United Nations Educational, Scientific, and Cultural Organization and is located above the Arctic Circle. It's a sizable size island, actually. What he found instead was a strange and unexpected sight. On a smaller Cologne Island to the south of Wrangel Island, more than 20 polar bears had taken up residence in buildings that were once part of the Soviet weather station.
Look at that.
Koch photographed the polar bears in their dilapidated homes and shared the photos on his website and on Instagram,
Wow.
alongside other examples of his dramatic marine wildlife photography. And the images struck a chord with viewers and quickly went viral. Wow, that's amazing.
It is.
He sailed 1,200 miles, which is 2,000 kilometers north to the islands from his starting point at Anadyr in the capital of Chukotka. Help me. Chukotka.
I gotta go back.
He noticed. Oh, no, it's okay.
I'm just
He
showing
noticed
pictures
that
while
there.
you're reading.
Oh, no, it's okay. He noticed that there was far more sea ice than is typical for Chukotka's northern coastline during the summer months. Abundant sea ice could explain why the bears were visiting Cologne Island instead of sticking to their usual summer territories further north, as polar bears use sea ice for hunting their seal prey. Cologne is so small, it's the tiny little island near Wrangel. You can see almost the whole island from your boat. And while there was once a Russian weather station on the island, it was abandoned in 1991 after the Soviet Union collapsed.
Mhm.
Shortly after, Koch's boat docked near Kolyachin to wait out a storm. Quote, "We saw some movement in the window of this weather station, and then we saw it was a bear. We saw one, then we saw another one, and then 20 of them, and they were all inside this building. They're living inside this building." It's so funny. To capture photos, he used a camera mounted on an aerial drone that had been modified with low noise propellers, making it quiet enough to slowly approach the bears without disturbing them. Inside the photos, the bears appear unconcerned about the camera and photographer. But when it comes to polar bears, looks can be deceiving. Quote, "Polar bears are very clever and sometimes tricky hunters. Sometimes they pretend they are not looking at you and they are relaxed. At this moment, they are ready to attack." End quote. Rawr. A nature reserve employee was with a group at all times, carrying a rifle and flares as a precautionary measure to ensure the team's protection. Polar bears weigh up to 1,700 pounds, which is 770 kilos. But for all that bulk, they are surprisingly quick, capable of galloping at 24 miles an hour, which is 40 kilometers an hour. Polar bears usually inhabit remote parts of the Arctic that are far from humans, but climate change is reshaping their habitat and has even driven bears to invade towns in the Russian Arctic in search of food. Since 1979, the sea ice that the bears depend on for hunting has shrunk and grown thinner. And researchers predict that summer sea ice could vanish from the Arctic by the end of the century. Though polar bears face an uncertain future, these images of the polar bears peering out from ramshackle buildings are a reminder that life on Earth can persist even as human-made objects and structures break down. But life will exist forever if only we care about it. So,
And I've
pretty
got all these
amazing.
little
So,
pictures on this. This article had all the pictures, and this one was here losing footing. They were out there losing footing on the, because
oh
the
wow.
ice is vanishing. Where's the ice?
Oh wow.
It says here, 2019, the ice hit its lowest extent on September 18th. And there's bath time. Oh my God, they're so cute.
Wow.
It's really a tragedy. Like Trulia said,
Yeah.
it's bittersweet to look at these. And they like to hop in the
So,
ocean and take a bath. They're beautiful. They're
oh,
magnificent
they are.
creatures. So that was that article in Live Science,
So,
and
So I
yeah.
have some information about Wrangel Island that I'm just dying to share with
Yes, let's
people,
hear this,
as you
Jen.
know. Right. So the very last place on Earth, and probably some of you already know this, but the very last place on Earth to have a healthy, sustained woolly mammoth population was where? Wrangel Island.
It was?
It was
Wow.
on Wrangel Island.
Oh
Yeah.
my
And
God.
Wrangel Island was not always an island. Wrangel Island, the sea has gone up over 400 feet in the last, say, 12,000 years.
Mm,
And Wrangel Island used to be connected to Siberia. And
that's fascinating.
there was a bunch of woolly mammoths that got marooned on Wrangel Island as the sea started coming up and up and up, and they couldn't get off. And so they only had that one population, and they just stayed there, and they eventually died out about 2000 BC. So they were persisting until 4,000 years ago. That was the last woolly mammoth population on Earth, was on Wrangel
Wow.
Island.
What what do you think about the fact that some scientists want to recreate the woolly mammoth and they say that that's going to help with climate change? I say bullocks.
What?
Yeah,
What?
that
Help
that
with
it can
climate
help.
change? I don't think
Yeah,
so.
somehow that the woolly mammoth will be able to.
No. I think they just want to recreate the woolly
Yeah,
mammoth.
well,
So
that's
knock
crazy.
yourself out. Do
Yeah,
it.
knock yourself
But
out. It's
climate
crazy.
change, knock yourself out. Go ahead, create woolly mammoths, make a zoo, make a Jurassic Park full of woolly
Oh my
mammoths.
God. That's
Go
kind of
ahead and get
crazy.
distracted by all of that and think that that's the thing that's going to save you for some reason. It's not.
I don't have
Um,
the article in front of me, but I probably could pull it up. Oh my gosh.
you know,
Well, we have been an hour and we are right on time, guys. This has been a really great show. I've enjoyed this. And I've enjoyed Jean and Tanya and Christopher and Dwayne and everybody that's been with us. Thank you for coming. Jennifer, would you like to tell us anything, any parting notes before I play the music and say la vie?
well, keep watching the methane. That's going to be an action-packed show. If all the methane were to melt, the temperature on Earth will go up a couple of degrees very, very quickly, instantaneously. So, those of you that like to watch methane and permafrost, which everybody at this show does, keep watching it. It's a fascinating topic.
Yeah, there you go. Oh. Jim says, I think it was to ride the woolly mammoths and replace cars. Okay, Jim, I'm going to give you a thanks, an applause for that one. We're all going to have our own woolly mammoth. Yeah. Hey, and
That would be like
JS,
a good novel. We could all be
right?
like riding our woolly mammoths or, you know,
Fantasy. Didn't saber-toothed tiger survive into Roman times? I thought I read that somewhere.
maybe,
I don't know.
maybe.
We
Well,
don't
we
know
still
much.
have some of the Ice
Yeah.
Age animals left, right?
Yeah.
We have the, what are those oxen? I can't remember the name of them, right? But those ones, there's still a few Ice Age animals left. Maybe the saber-toothed tigers did. I don't know anything about the saber-toothed tigers.
I
That's
don't either. I don't either, but all of these things are interesting food for thought for next shows. We're always but we do love to do our Arctic shows together. Jennifer and I just look forward to this big time. And thank you, Hunter. Okay, Hunter says, "Buy me a coffee."
Thank you,
Thank you
Hunter.
all. Thank you all. All right. So I think I'm just going to end with some music. And Jennifer, till we meet again next week, maybe we'll have a something. Who knows? Who knows? I'm gonna play our comments, play some music. Love you all, Jen. I love you too.